Hello and welcome to the video on Unit 1 practice questions or Chapter 1 practice questions. I have selected a few problems that we could look at together in this video. I've also submitted this answer keys, so if there is a problem, if you have an issue with any question, just let me know and I can work it out and I can create a video for you. So let's look at this one. Two cities, A and B, have the populations of 1.3 times 10 to the 6th and 5.8 times 10 to the 5th respectively. How many times larger is city A than city B? So whenever you're asked how many times, that means that you will need to divide. So we're taking 1.3 times 10 to the 6th, and then we're dividing that by 5.8 times 10 to the 5th to see how many more times is this city A larger than city B. So simply, you can just use your graphing calculator and just type this in, enter this value, and so we have 1.3 times 10 to the 6th, so 10 to the 6th power, and we want to divide that. Now let's make sure that I need to lower my exponent, so I need to, yes, so divide it by parentheses, and we have over here 5.8 times 10 to the 5th, 10 to the 5th power. And now let's go to the right one more time to lower the cursor, close the parentheses, and we have the first city is about 2.2 times larger. So let's put that down, so 2.2 times. Now, B, the two cities are combined to make a new city C. Write the population of C in scientific notation. So what that means, we have to add the populations of both towns to get what that new population of town C is. So when you put that in your calculator, you will get that the population of new city C is 1.88 times 10 to the 6th power. Now C is asking by what percent has city A grown due to the addition of city B. So what they're asking us is percent growth. So we're going to take the city C and we're going to divide it by the city A population to see what's the percentage growth. So 1.88 times 10 to the 6th power over 1.3 times 10 to the 6th power. And we get that we want to multiply that by 100 because we're going to get a decimal, and that turns out to be 144.6%. Now, if the original city A was 100%, we have to subtract that to get what is the percentage growth. And this turns out to be 44.6% is the percentage growth. Okay, so let's look at problem number 9. So let's change the color over here. So number 9, we have the distance from Earth to another planet in solar system is 5.8 times 10 to the 8th. Light travels at the speed of 300,000 kilometers per second. Calculate the time taken for light traveling, leaving the other planet to reach the Earth, writing your answer in scientific notation. Let's just sketch over here what's the situation. So we have Earth and we have another planet. So we'll just call it P. And we have the distance between Earth and this other planet is 5.8 times 10 to the 8th kilometers. Now, we're given what the speed of light is. So this is C. And we need to find out how long does it take for the light to reach from one planet to Earth. So what we're going to do is we're going to use the distance formula. And you remember, distance formula is rate or speed times time. So we're given that the distance, I'm going to substitute now, the distance between planets is 5.8 times 10 to the 8th power kilometers. And over here, rate is 300,000 kilometers second to the first, which is kilometers per second, times our time. So we don't know what the time is, that's the unknown variable. To solve it, we have to divide both sides by 300,000 kilometers per second. So kilometers, so dividing both sides, 300,000 kilometers per second. We're going to cancel kilometers and kilometers, cancel these units. And we have the time, when we divide this, we get that the time is, we have 1,933.3 seconds. So that's the time to for the light to reach from one planet to Earth. Now it says writing your answer in scientific notation. So what does that look like in scientific notation? So we're going to move our decimal point 1, 2, 3 decimal places to the left. So we're going to put 1.93 times 10 to the third seconds. Now part B is asking us, write your answer to correct to the nearest minute. So we can do this different ways, but one of the ways is 1.93 times 10 to the third seconds over 1 times, in 1 minute we have 60 seconds. The reasons why we're setting this up, we want to cancel seconds and seconds. And so now to find out how many minutes is this, we're going to take this number and divide it by 60. And this turns out to be approximately 32 minutes. Okay. And then let's look at problem 11. So let's do problem 11 together. So we want to write this expression 4 to the x 16 to the negative 2x over 32 raised to the x power as a single power in base 2. So first of all, I'm going to see if I can extend this page. Okay, I got the page extended, so just a little bit lower. Okay, so let's rewrite. Okay, here we go. Let's rewrite 4 as 2 squared, and then we're going to raise that to the x power. 16 we can rewrite as 2 to the power of 4, and that raised to negative 2 to the x power. And then 32, we know that is 2 to the 5th, and they then raise that to the 5th power. Now let's simplify this. Using the power rule, we're going to multiply 2 times x, so this is going to be 2 raised to the 2 times 2x power, so this first part. The second part, 4 times negative 2x, so this will be, so 2 raised to the 4 times negative 2x, that's negative 8x. And then the last one over here is 2 to the 5x. Now, we're going to use the multiplication rule. So with two bases being multiplied, we're going to add these two exponents. So what we're going to end up is 2x minus 8x, that's negative 6x, and then 2 raised to the 5x. Now the quotient rule tells us to subtract, when we're dividing powers that have the same base, we're going to subtract the exponents. So let's do that. Negative 6x minus 5x equals 2 to the negative 11x. Now, to rewrite this with the positive exponent, we would write it as 1 over 2 to the 11x. Thank you for watching. I hope this video was helpful.